when you multiply, when you multiply, look, when you multiply conjugate, suppose radical 2 plus radical 3 times radical 2 minus radical 3. This is a conjugate, right? It's square the first gets 2 minus square the second gets 3 because radical 3. And the answer is negative 1. Unbelievable. The answer is just a number. Do not contain radical. You have 1, 2, 3, 4 radical. Disappear the radical. In this case, you have 2 radical. Radical 5, radical 5. No, the answer is just real. Real, no. This expression do not contain radical. And this is the fantastic way that we are doing for rationalization. But rationalization, when you have binomial. Let me try rationalization one more time. 15. Okay, no 15. Let's move on to the question, to worksheet 19.
Can you move up?
Yes.
Since you did not record 12.
Yeah, I recorded now. Oh, no.
Okay. Okay, 12.
12.
Okay.
Okay, so let's move on to the page worksheet 19, que is the last part of the review packet for the test 4. Okay, is question 1, 5 over radical 2x. And the question says rationalize the denominator and simplify. Okay, so the question says rationalize and simplify. Okay, this is classic. Rationalize means eliminate the radical in the denominator to say multiplication by radical 2x. So in the top we have 5 radical 2x, and the bottom you have just 2x. Final answer. Super easy. No more simplification, no. Impossible. Nice. Number 2. Number 2 is more complicated because when you have higher root, it's a little bit more complicated. It's a cubic root 2x squared. And my goal is remove this radical. Entonces, no similar to this. No, well, yes and no. Okay, I know. Okay, to eliminate the cubic root, we need 1, 2, and 3, 2. Okay, by the way, the cubic root, I know the cubic root of a, que es 2 times 2 is 4 times 2 is 8, is 2. So to eliminate this radical, I have in my original problem 1, 2, que es this. We need 2 more. In this case, no. In this case, it's easy because it's a square root. So square root 4 is 2, and this is 2 times 2. So we have 1, 2, and the original problem is this. We need only 1 more extra to get this. But this is square root. Si es cubic root, you need 3. Si es 4 root, you need 4, and so on. Entonces, the smart one is not obvious. It's cubic root 2, 2, because we need 3 in total. And likewise, cubic root of the x cubed is x without radical. So we need 3x, but we have 2. We need 1 extra x. And you, in order to doesn't change our original problem, this is the smart one that I create. Do you see or no? Complicated or easy? I know it's hard, eh? Easy, okay, no, okay, understand, very well. Let's do it. So now, in the top part, we have 4, this 4 stay, this is 2 times 2 is 4, we working according to the situation, cubic root 4x, right? Where come from this 4? 2 times 2. And the bottom part, we have only 2x. Yes or no? Because when you put this and this together is cubic root 8, because 2 times 2 times 2 is 8, x to the cubic power. Y I know que cubic root 8 is 2, and cubic root x cubic is just x. And that's it. No, a simplification, divided by 2, 1, divided by 2, 2, and the final answer is 2 cubic root 4x divided by x. Final answer. This is a little bit complicated. And the higher root.
Can you explain the
Again?
third? Can you explain the third step again?
Okay. This is my original problem. I need to do something to rationalize. So my final answer, okay, is this. 2 cubic root 4x divided by x. Do not contain in the denominator radical. This is radical. This is not radical. No, yes. I need to do something. This is 2, no? Sorry. This is 2. Entonces, as always happen, I need to create a smart one. The smart one is not easy to see because when it's a square root, it's obvious because it's the same. No, in this case, no. Is you put a cubic root, the same index, cubic. But I know que cubic root 2 times 2 times 2 is 2 without radical. So I need complete the amount of 2 that we need. See, we have 1, 2, and we need 3. We need to put artificially 2 more extra. And likewise, in x, well, I know que cubic root x times x is x without cubic root. So we have 2, I need to put only 1 extra. In order to doesn't affect my original problem, I divide it and multiply by the same expression. This is my smart one. Let's do it. The multiplication is super easy. 4 multiplied by the number in the front. Guess what? Inside the radical state, 4x. And no possible simplification anymore. In the bottom, it's 2x. Only 2x because when you put this and this together, it's cubic root 2 times 2 times 2 x squared times x. We have x to go outside like 1, 2, and this is 3x. Is exactly the amount of x we need to go 1x outside. Now inside we have nothing. So we eliminate, fantastic, the radical. The last step is simplification 4 and 2. Like
you need to squeeze the screen.
Okay. Like that.
Better.
Like that. It's okay. You see now?
Yes.
Okay. But the most important is, you understand the idea or no? Noela?
Yes, I did.
Okay. Entonces help me, no? So you ask me a question. I try to explain. I know no answer. Entonces, what is the conclusion?
No, Professor.
Again, your internet is wrong.
Yeah, unfortunately.
Okay. Let's move on to number 3. Number 3, again, is easy. It's no big deal. So the majority of the problem, all the problem you see in the test is no cubic root. It's a square root. And rationalization part. And other no. Number 3 is square root 8 over 3xy squared. Entonces, immediately I separate. Es radical 8 over radical 3xy cubic, y square, sorry. Entonces, I focus in the top. A is 2, 4, 2, 2. Oh, yes, I have a couple too. Outside. Entonces, this is 2, radical 2. This 2 is this 2, and this 2 is this 2. And the bottom is super easy. Is this y square is a couple of y, represent one y outside. I finish? No, of course no, because you need to rationalization. Rationalization is multiplication by radical 3x. Radical 3x. Now we have in the top we have 2 radical 6x over, and the bottom we have 3xy. Because radical 3x times radical 3x is 3x, and y stay alone. And this is the final answer. Do you see or no? Do you see or no?
Yes, perfect.
Yes, perfect. Good.
We didn't y because we want to eliminate the root, right? We want to eliminate the root.
Yeah, the idea is eliminate the root, pero in the denominator part. Okay.
Okay.
So in general, rationalize. In general, the word rationalize indicate eliminate radical. Entonces, when there no specification, you default suppose que es in the denominator. Okay. Another problem is specification. No, rationalize the numerator. Okay. But this is very, very weird. Okay. Super. Let's move on to number 4, 5, and 6. Problem is different, completely different, because in the bottom we have binomial. Suppose number 4, in number 4 we have 14 over 3 minus radical 5. Okay, what is the difference? The difference is, suppose that one problem is stupid problem. Multiplied by radical 5, 14 radical 5 over 5. End the story. That's it, I finish. But in this case, no, because it's binomial, two guys, separated by plus or minus. So you create also a smart one, but a different smart one. Que es the conjugate of this. It's 3 plus radical 5. It's a conjugate. It's a conjugate. Y I know que the multiplication for the conjugate, two conjugate, the answer that we get here do not contain radical anymore. This is the idea. One more time, we apply the formula. A minus B multiplication A plus B is A squared minus B squared. Entonces, like 3 squared que es 9. So this is, in our problem, this is the A is 3. Radical 5 squared. Pero radical 5 squared is 5, and always minus in between. Look at that, minus. And 9 minus 5 is 4. This is magic. How we eliminate this radical? Multiplication by the conjugate of the expression in the denominator. In the top now, in the top multiplication, 14 times 3 is 12, 42, no? 42 plus 14, 5. 42 plus 14 radical 5. Now we can simplification. I suppose que yes, because 42 divided by 4, no, es decimal. Pero you can simplification a little bit. 42 plus 14 radical 5 over 4. We can simplification a little bit by 2, yes. It's 21 plus 7 radical 5 over 2. So the thing I did was divided by 2, not by 4, by 2, by 2, and by 2. And by 2 only, the number outside and the number inside the radical stay the same. And this is the final answer. Okay, so the fantastic conclusion to rationalize when you have binomial in the denominator, well, you create the smart one again, but this smart one is different. It's a little bit more complicated. It's the conjugate of the expression in the denominator. Okay? The expression in the denominator. Okay, let's do number 5. Number 5 is radical 8 over radical 3 plus 1. Okay, entonces immediately I realize que this is the rationalization binomial. Entonces I create my smart one, que es radical 3 minus 1. Opposite sign. Entonces in this moment I realize I want to multiplication first this and this, because I know que es a special product, and this special product, the answer do not contain radical. Radical 3 times radical 3 is 3, always minus, and 1 times 1 is 1, and 3 minus 2 is 2, minus 1 is 2. And the top is radical 3 times radical 8 is radical 24, and radical 8 times negative 1 is minus radical 8. And we can simplification. I have no idea, but let me try. I focus it in the top part, radical 24 minus radical 8. 24 is 212, 26, 23. Oh yes, I discovered a couple of 2. Okay, entonces this is like a 2 radical 6. Okay, this 2 is this 2, and this 6 is 2 and 3 together. And radical 8 is 2, 4, 2, 2. We discover again a couple of 2. Entonces 2 radical 6 minus 2 radical 2. We can addition or subtract? No, we cannot, because it's different radical. But you can divide, yeah, you can divide. 2 divided by 2 is 1, entonces the answer is radical 6 minus 2 divided by 2 is radical 2. This is the beautiful final answer. I like this. Okay, she like. Okay, rationalization when you have binomial. The last problem is number 6. Number 6 say x plus 3 divided by radical x plus radical 3. Okay, I create my smart one, que es radical x minus radical 3. Radical x minus radical 3. Yeah, I know that the denominator part we have x minus 3. Yes or no? X minus 3, que es this time this and this time that. And always minus in between. Remember the fantastic formula, a plus b times a minus b times is equal a squared minus b squared. This is this, and this is this. Therefore, this sign is always minus. And the top, well, it's crazy multiplication, but you fall, and that's it. X times radical x is x times radical x. X times radical 3 is minus x radical 3. And this is plus 3 radical x. And the last one is this and this, que es minus 3 radical 3. We can combine, of course we can combine. We can combine always when you have the same radical. I discovered here the same radical, look. Entonces es, well, on the bottom stay x minus 3. Entonces radical x I factorado, ¿no? Entonces we have x plus 3, ¿no? X plus 3. Look, this x is this x is this, and this 3 is 3, this 3. We can combine more, yeah, of course, because we have another radical. This is 3. Okay, is radical 3, radical 3, and radical 3 is minus minus radical 3 is like a common factor, a great common factor. And we have x plus 3, no? X plus 3. And leave it like that. You can, but no. I can see it's similar. And this is the common factor, x plus 3. And you open the last parenthesis, radical x minus radical 3 divided by x minus 3. Wow, entonces we come back. Look, we come back. Okay. Here, something is redundant because we come back. This expression is exactly the same, the multiplication this and this. And the only thing it changed is the bottom part is x minus 3. Entonces you can leave it like that, maybe yes, or like that, without grouping here, or like that, it's the same. You know, guys, in algebra, we have no one unique solution. So when you manipulate algebra, you find different solutions and they are equivalent algebraically. Entonces, for example, when you're solving something, no equations, no simplification, and you go to the back of the book to see the answer, you see, wow, I make a mistake. No, the answer in the back of the book is similar, equivalent to your answer, but the only thing the author of the book doing different way like you, using another criteria, another manipulation, but your question is, your answer is good. Okay? Okay, so now remember the idea of the rationalization. Let me try to recap. Okay, one easy monomial. Suppose 1 over radical 2. How you rationalize this? Bueno, you create the small one, radical 2. Entonces in the top we have 1 times radical 2, que es radical 2 divided by 2. Así. Suppose que I complicate your life. I put radical cubic root of 2. How you rationalize? Well, you put another, but you put 2, no 1, because in the index of this case was 2. Default, it's invisible 2, no, but exists 2. In this case, no. Entonces, cubic root 2 times 2, because I need 3, 2. The answer in the bottom is 2, because 2 times 2 times 2, so you put together condensing only one radical. 2 times 2 times 2, we have exactly the amount of 2 needed to put 1, 2 outside without radical. And the top, we have cubic root of 4. And this expression is equivalent to this. But this expression do not contain radical in the denominator. Super. Now binomial. In the binomial, suppose that you have 10 radical 2 plus radical 5. How you rationalize? Well, you create the conjugate, que es radical 2 minus radical 5. Radical 2 minus radical 5. I multiply first the bottom part, que es 2 minus 5. Okay, this time this, and this time that. Okay. Guy, you apply foil or no? You can, but of course, the inner and outer factors is always cancel out. Let me show you. Radical 2 times radical 2 is 2. Radical 2 times negative radical 5 is minus radical 10. And radical 5 times is positive radical 10. And this is minus 5. This is always, I guarantee you, gets cancelled when it's conjugate, of course. And 2 minus 5 is negative 3. The answer is negative 3. So the shortcut is using the formula. What formula? That formula. A plus B times A minus B is equal A squared minus B squared. A, in our example, radical 2 squared is 2 minus B is radical 5 squared is 5. Minus 3. Exactly the same it is here. In the top, no. In the top, you multiplication is 10 radical 2 minus 10 radical 5. And we can combine this radical. No, because it's different radical. And leave it like that. 10 radical 2 minus 10 radical 5. Some people say, well, okay, professor, yeah, I can factorization 10. You can, of course. But not necessary. Okay, 10 radical 2 minus radical 5 divided by negative 3. End the story. Another student say, I don't like this negative. Okay, me too. You change to say 10 over 3 positive to say radical 5 minus radical 2. It's another possibility. In my opinion, this is more elegant. But it's okay. This is okay. And this is super okay. Okay? Clear? Confusing? Sorry, it's too fast, but this is the review. Okay? Are you ready? Are you ready to start chapter 5? Chapter 5 is relatively easy. So you almost finish this. Chapter 4 a little bit, chapter 5 super easy. Everyone get 100 points. I guarantee you 100%. Chapter 5. Chapter 3 is the most complicated part. Great. Okay, no, it's easy. It's easy. Okay, what is the first part in the chapter 5? It's a radical equation. So I am switching to the another package I sent today. Suppose we have this equation. Q plus 1 equals 7. So what is the confusing part in the radical equation? Radical is equation that contain at least one radical. Equations. Is the complicated part or the picky part is that when you solving the radical equation, you need to mandatory verification the original, the potential solution into the original equation. The reason is because when you transform a little bit this equation in the way I want to explain right now, this new equation gets easier than the original because do not contain fraction, of course. Fraction no, radical, sorry. It's not equivalent 100%. Maybe you get something is called extraneous solution. So any solution that you get, you need to plug it in the original to verification that this statement is true. Sometimes happen, it's seldom que happen, pero happen that something is not true. Entonces you can see that this solution is wrong. Okay, entonces I never touch the original equation, never, because I want to waiting for the moment of the checking part. It's mandatory. Okay, I rewrite again. In order to eliminate the radical, you square both sides. Because I know that radical any expression square is equal to any. So you copy q plus 1 equal 49. Because 7 times 7 is 49. And you get the easier equation than the original. Now q is equal to 49 minus 1 is 48. And the potential solution is 48. This is potential solution. And you need to do the second part, the checking part. Okay, you checking for q equal 48. Where? In the original equation. I need to verification that 48 plus 1 should be 7. I claim this statement because I am not sure it's true or false. In this case, it's super true because 48 plus 1 is 49, and the square root of 49 is 7, second equals 7. This statement is completely true, it's okay, and the solution is 48. But sometimes happen que no. I don't know if you see here or no, and this example can bring here, but you need to check it. It's mandatory. And the test on paper, I want to see solution, get the left part, and checking get the right part. So you omit that part, no credit for you. Because you omit one important concept, que this radical equation need checking. Okay, another equation, no, but this, yes. Clear? Confusing? Let's do number 2. Number 2 is similar. Number 2 is similar because it's easy because contain only one radical. 7 cubed minus 6 equals 6. Okay, I copy again. I never touch the original, waiting for the checking moment. Square both sides. Those square and square root cancel out each other. It's 7 cubed minus 6 without square and square root equal 36. 6 square. 7 cubed is equal 36 plus 6 is 42. Divided by 7, divided by 7, divided by 7. Cube is equal to 6 divided by 42 divided by 7. Now the checking part. The checking part is I need to verification the square root 7 times 6. I replace cube for 6 minus 6 should be equal 6. This is 42. And 42 minus 6 is 36. 6 equals 6. True. The solution is perfect. Solution is 6. Q equals 6. Leave it like that, or you enclose in the box. Yeah, I understand very well that this is the final answer. Good or not good? Now be ready. Be ready for the next. It's very, very complicated. It's when you have two radicals. Ow. Two radicals, very, very complicated. Because when you have, no, number 3 is one radical, of course. Okay, number 3 is easy. One radical is easy. 5 cubed plus 6 equal 6. Okay. I copy. I square. So the key idea in radical equation is you have a radical and you eliminate the radical where? Square. In the right hand side, when we have a number, square. And this is cancel out mentally. So the 5 cubed plus 6 equal 36. 5 cubed is equal 36 minus 6 is 30. Divided by 5, Q is 6. My potential solution, I need to check. Plug it in. Square root 5 times 6. That's true, it's obvious. Plus 6 should be 6. But I claim always, no, this is 36. This is 30 plus 6, 36. Now the square root of 36 is 6. 6 equals 6, true. The solution is 6. Do you understand very well this, right? Radical equation using only one radical. Because I want to complicate a little bit your life using two radicals. Equation que contain two radicals. And we can eliminate both? No. No. We can eliminate one by one. It's impossible. Impossible. Eliminate both simultaneously. No. It's crazy. Some people try, but no. I'm sorry, because those are now it's too long process. Because what is the rule? You eliminate one radical first, manipulation, and try to isolate the second radical, can stay alive, and eliminate again using the same key idea. Remember, the key idea is square root any expression. When you square, disappear the radical. Okay, so I copy again my equation because I using the original for the checking moment. And you square here and here. Okay, by the way, when you have a plus b squared, binomial square, is not equal a squared plus b squared. This is wrong, coño. Okay, this is completely wrong. This is the typical mistake. Okay, no. This is no. The only thing you should do is a plus b squared is a plus b times a plus b. And you FOIL here. Or the formula que frequently we are using, but the student I don't like, I don't know why. Case, look. Square the first, plus twice, multiplication both, plus b squared. So this is quick FOIL. This is the regular FOIL, the student like, and this is completely wrong. The student can do in 3 squared plus radical x minus 4 squared, 0. Your grade is 0. Okay? No. Quick FOIL or FOIL? You let me know what do you prefer.
Quickly FOIL.
Quick FOIL, okay. Me too. Okay. Entonces, in the left-hand side of the equation, it's easy. It's only the square and the square root. Let's cancel. Now you apply quick FOIL. Quick FOIL or just FOIL? Quick FOIL or FOIL? Or regular FOIL, like a kindergarten guy? What do you want? Kindergarten or college way?
College.
College way, I know, que es square first, kindergarten. No, okay, I respect. Some people say, no, professor, I never learned this quick FOIL. Okay. I want to explain using both ways. At least the first, the last, this moment. Now, see, you believe it's much better for you continue doing FOIL, okay, FOIL, and that's it. And this is a shortcut, and this is not a shortcut. Okay, I want to do by the kindergarten. Okay, kindergarten say 3 plus radical x minus 4 times 7. You ignore que they are twin brothers, okay? And your multiplication. 3 times 3 is 9. 3 times a radical is 3 times a radical. And remember, we cannot mix it, number or expression, inside outside. I suppose que the number here is 1, que is invisible, no? Entonces 3 times 1 is 3. And the radical times 3 again is the same. Now, a radical times a radical, is the expression without radical. Because I know que radical any number or expression times radical any number or expression is any number or expression without radical. So x square root x minus 4 times square root x minus 4 is just x minus 4. And that's it. Another student que I using quick FOIL, remember the formula is que a plus b is a squared plus twice ab plus b squared. A in our example is 3. And 3 squared is 9. So this is this. What is the reason twice? Because 3 plus 3 is 6. So this is, I know que this is a special product. And they are twin brother, and they are repetition. So actually, no, 3 is 6, because 3 plus 3 is 6. And square the second, I square the second is, this guy. The second is radical x minus 4. When you square, become x plus 4 without radical. Okay? Okay, guys? Doesn't matter. Either way. Then, my equation so far is 3x plus 1 is equal 9 plus 6 radical x minus 4 plus x minus 4. Everyone follow me so far? So far it's okay? 3 plus 3 was 6 because it's the same radical. I can't. I can't do that. Put together. So 3 radical any plus 3 radical any. If this any is the same, of course, it's 6 radical any. Okay, now we combine later. 3x plus 1 is equal 9 minus 4 is 5. I put it here, well, either way. Plus x, this x is this x, plus 6 times radical x minus 4. Okay, what is my goal now? What is my goal now? My goal is, I have another equation. In this moment, I have another equation. Okay, I suppose it's equivalent to the original, but this equation contains only one radical. And we are doing before. My goal is isolate the radical, isolate the radical, isolate the radical, the expression that contains radical, and apply the key idea one more time. Key idea is radical any, you square both sides. It's the right hand side square, and you destroyed the second radical. And so we have one equation, finally, definitely, okay, do not contain radical, and I try to solve it. Okay, to say 3x plus 1 stay here, minus 5 minus x equals 6 radical x minus 4. So I move 5 and x to the left, because my goal is isolate the expression that contains radical. 3x minus x is 2x. And 1 minus 5 is 4. In this moment, not mandatory, but I like that way. I can see that the coefficient is even number, 2, 4, and 6. There are no reason to stay. I can simplification a little bit. You divide by 2, divided by 2, divided by 2. But no by 2 inside. You divide by 2 outside. Remember, inside the radical, outside the radical, belong to the different category. We cannot do that. So x minus 2 is equal to 3 times radical x minus 4. This step is not strictly mandatory, but it's good. Why? Because so you're working with the 6 when you square 36. However, in my case, it's 3 when you square 9. Those are scissors. And now, what is the key idea? The key idea is square again. You square here, and you square here. Square both sides. Okay, and now it's a binomial. You are doing exactly the same. Kindergarten, FOIL. And binomial is monomial because you consider a square root like one package, like one object. But it's 3 squared and square root x minus 4 squared, something like that. It's 9, and square root and square cancel out. It's x minus 4. But be careful. You put a parenthesis here because this 9 multiply not only, so you omit the parenthesis. I suppose que 9 multiply only the x here, time. This is wrong. This is important, this parenthesis is extremely important. This is the most important thing, in my opinion, in this example. Now you foil, like a kindergarten guy. This is x squared minus 2x minus 2x again, repetition, 4 plus 2, plus 4, sorry. 2 times 2 is 4. This is x squared minus 4x plus 4 equal, and the right hand side, you remove the parenthesis, apply this trick of the property, 9x minus 36. Okay, in this moment I realize we are in from the quadratic equation. Quadratic equation. How do you know? Because this exponent is 2. When this exponent is 2, it's quadratic. When this exponent is not 2, it's 1, it's linear. And the linear you solve is super easy. And quadratic is easy also, but it's a little bit more complicated. You solve them by factorization. Then you bring everything to the left. X squared minus 4x plus 4 minus 9x plus 36 equal to 0. And we combine later. X squared minus 13 x plus 40, no? 40. Yeah, 44 and 36 together is 40. Now we have in that moment a regular trinomial, easy. And the key to open the door is 8 and 5, because 8 times 5 is 40, 8 plus 5 13, negative both, same sign, equal to 0. So we have the solution, 8 and 5. And this is my potential solution. Entonces en that moment the student finish and don't check it. 0 point. No credit. Sorry. Sorry. This is intermediate algebra. This is no kindergarten algebra. This is no, we have another level, was the kindergarten way. Okay. And you need to check it for both solution, for A and 5. So I go, let me use another color for differentiate the checking part. And the checking part we separate in two pieces because I need to check it for x equal 8 and for x equal 5. And substitution where? In the original. Okay, I never touch, waiting for that moment. Okay, it's a square root 3 times 8 plus 1 should be claimed that, because I'm not sure it's true always, 3 plus something. 3 times 8 is 24. 24 plus 1 is 25. A square root 25 is 5. 8 minus 4 is 4. Square root 4 is 2. Oh, it's true. Therefore, A is okay. A solution. I don't know what happened with the 5. Square root 3 times 5 plus 1 should be equal 3 plus something. Square root 5 minus 4. 3 times 5 is 15. 15 plus 1 is 16. Square root 16 is 4. It's 3 plus something. 5 minus 4 is 1. Square root 1 is 1. It's true also. So in this case, we have two solutions. No, sometimes no. Sometimes one solution works and another doesn't work. But in this case, no, work both. And the answer is the option A. Any question? Come on. This is a moment to ask me a question. It's super long because we have two radicals. What is the idea? The idea is isolate one radical. It's long. Sorry. It's not my fault. I just a teacher and explain the idea. You isolate super long. Okay, super long. So you have 3 radicals. It's more long. But no, you never see 3 radicals. So you isolate one radical, you square. No cry. But do you understand the procedure or no? You have to practice first. And the other, you can see several problems with this. I understand. You understand. This is the most important thing. Can you understand? So you understand, you try. The other is practice. Let's move on to the 5 problem. 5 problem. 5 is square root 2x plus 3 equal no, it's equal, it's minus square root x plus 1 equal 1. What is the typical mistake I saw every day? Some students say radical something minus radical something equal 1, and you square both sides. And you see this something minus this something equal 1. This is wrong, completely wrong. You cannot do that. You need to isolate one radical. In this case, this is the new thing that brings me that problem, no? Okay, the 2 radical is located in the left hand side. So you make a decision what radical you want to isolate. For example, I want to isolate equal 1, no? I want to isolate the first one. I move the second to the right hand side. Okay, now ready. Now ready to eliminate at least the first radical. Entonces 2x plus 3 is equal, and you FOIL this like in kindergarten, guys. 1 times 1 is 1. 1 times a radical is a radical. A radical times 1 again is a radical. And a radical times itself is the expression inside without radical. Do you follow me? Do you follow me? Good. You like this way. It's the kindergarten way. Okay, super. Now we combine like term. 2x plus 3, I just copy. 1 plus 1 is 2. This one and this one is 2. There are no reason to have 1 in the first part and 1 in the last part. No. Together, combine. And x. And the radical is the same as twice. So you isolate the second radical now. 2x plus 3 minus 2 minus x is equal to radical x plus 1. And one more time, we combine like term. 2x minus x is 1, and 3 minus 2 is 1. Okay, ready. Now ready to square both sides. Because I have only one radical, I want to eliminate the second. Entonces now es x plus 1 times itself is equal 4. We confront this 4 to the second power. Parentheses, don't forget the parentheses, x plus 1, because I know the square root and square cancel out each other. Basically, this is you distribute the property of 4x plus 4. And the left hand side we FOIL. It's x squared plus x plus another x, always twin brothers, plus 1 equal 4x plus 4. Okay. In this moment, we combine. This is 2, this is twice. And I realize we are in front of the quadratic equation. I put in a standard for. Standard is when the right hand side is 0. And again, we combine like that. Entonces, minus 2x because it's 2, minus 4 is negative 2, and 1 minus 4 is negative 3. Okay, in this moment we have quadratic equation, but we have trinomial, regular trinomial, and so far the only possibility to the factorization is 3 and 1, no? 3 and 1, because 3 times 1 is 3, 3 minus 1 is 2, different sign, of course the minus is 3 and positive 1. One solution is 3, another solution is negative 1. And this is my potential solution. I need to verification one by one into the original equation. Okay, original equation verification using red color. X equal 3, plugging into the original is square root 2 times 3 plus 3 minus square root 3 plus 1 should be 1. I claim this statement because I'm not sure it's true. 2 times 3 is 6, plus 3 is 9, square root 9 is 3, minus 3 plus 1 is 4, square root 4 is 2, equal 1 is true. Solution 3 is good. Checking that. And negative 1, square root 2 times negative 1, plus 3, minus square root negative 1 plus 1 should be 1. This is negative 2. Negative 2 plus 3 is 1. Square root 1 is 1. Minus negative 1 and negative 1 is 0. Square root 0 is 0. And 1 minus 0 is 1. Yes, it's true also. Therefore, both solutions are good. Solution set. This is a potential solution, but I verification because both are true, plugging into the original equation. Now, solution set is both together. Like the option 3 and negative 1. B, no? Any question, guys? Equation. One more or no? One more or no? One more, no? And the last one. Yeah, that's it. No question. Okay. You have to practice. I know that you have to practice. This is the key idea in mathematics. Practice, practice. You, Noela dice, no, no what? You understand the concept?
Yes,
Now you manipulate. Pero we have time, no? We have 10 minutes, no? Let's do in the last one. Yeah. Let's do in the last one. I promise it's the last one. Number 6. Just in case, when I finish, I want to send the... Well, first of all, I need to download. I download the video. I send to YouTube in your correct place. And I send back the hyperlink connecting this. Always I am doing this, right? And this email, I want to explain for everyone the idea that we're discussing at the beginning, that we extending a little bit to the April 13, no? The due date for the, so I need to change in Alex. So April 13 is the due date for the test on paper, for the test online, for the homework online. Okay, I need to change right now. When the class is over, I want to change in Alex. Yeah, I send to you this. Okay, I agree or disagree?
Agree.
Okay. Entonces, 2x plus 5 minus square root x minus 2 should be 3. Again, it's impossible eliminate two radicals simultaneously. No. Therefore, you isolate one. And you square both sides. When you square, you have 2x plus 5. Nice. I eliminate the first radical. Good. I like that. And your multiplication to binomial, the only possibility to multiplication binomial is FOIL. You know very well in the elementary algebra. Okay, so you multiply 3 times 3 is 9. You multiply 3 times a radical is 3 times a radical. And a radical times 3 is 3. And this is all we have because they are identical. And this is expecting because they are twin brothers. Plus the last is x minus 2 because it's the same expression inside the radical. Now you have 2x plus 5 equal 9 plus 6 radical x minus 2 plus x minus 2. Now we combine like term. The only like term that we have is 9 and 2 gets 7. Okay, so what is my goal? My goal now is isolate the second radical. The only radical stay alive. Entonces 2x plus 5 minus 7 minus x is equal to 6 times x minus 2 radical. 2x minus x is 1x minus 2 because 5 minus 7 is 2 equals 6 times. In this case, no, coefficient here is 1, coefficient is even. You divide by 2, no, because of 1 here. And you square. When you square, this is 36. 6 squared, 36. Multiplication x minus 2. Don't forget this parenthesis, is super important. And x minus 2 times itself is x squared first, power minus 2x, inner minus 2x again, plus x plus 4. So actually we have x squared minus 4x plus 4. In the right hand side we have 36x, and this is 72, no? Minus 72. Let me check in just in case. Yeah, it's 72, it's obvious. So we have in that moment quadratic equation. Quadratic equation. Oh, quadratic equation. Wait a second. Let me try to manipulate the quadratic equation. Entonces es x squared minus 4x plus 4 minus 36 x plus 72 equal to 0. I move everything to the left. And one more time we combine like that. It's minus 40 x plus 76 equal to 0. Wow. Entonces in this case it's a little bit confusing. But this is motivation for the next class. Okay, you know, normally when you get this moment, the thing we are doing is factorization. Factorization. Factorization.
Killer.
No, I don't care this. Okay, factorization. Okay, the factorization here is a little bit complicated, right? But don't worry. Ah, carajo. Okay, the motivation is, I know the answer. What is that? The answer. However, I put this example to motivation, to the thing we started in the last class, because in this case it's a little bit complicated to find the combination. What is the key to open the door? Wow, I don't know. Okay, entonces 38 times 2 es 76. 38, 38 and 2. Entonces, you understand it's a little bit hard to find the combination. Not always is easy to find the combination. This is the classical example que es hard to find the combination, same sign, both negative, right? One solution is 38 and one solution is 2. So I promise in next class we study another way to solving this idea, another more complicated quadratic equation. We're using one formula, and the student likes so much using the formula because the formula is like a foil it's like a kindergarten que you solve it always in the same way. I finished, or I gotta go, or no? Or I need to check it? Mandatory check it or no? Yeah, of course.
Yes,
It's square root 2 times 38 plus 5 minus square root 38 minus 2 should be 3. I claim this statement. And also square root 2 times 2 plus 5 minus square root 5 minus 5, no. 2 minus 2, no? Because the thing I'm checking is 2, x equal to 2 minus 2 should be 3. Okay. Entonces poneme a calculero. 38 times 2 is 76, no? This is 76. You remember that. And 76 plus 5 is 81. And the square root 81 and 9. Minus. This is 38 minus 2 is 36. And the square root 36 is 6. And 9 minus 6 is 3. Good. Let me see the second one. The second one is 2 times 2 is 4. And 4 plus 5 is 9. And the square root 9 is 3. Minus 2 minus 2 is 0. And 3 minus 0 is 3. Both are good. Unfortunately, you don't see some example that fail the solution, but sometimes yes. If you want, next class I bring one example that fail. Yes. Okay. That's it for today. Say goodbye and wish me have a nice day, Professor. You too.